It's one of the best-kept secrets of space science. For transporting ambitious and hefty scientific experiments to near space. Though they're not as flashy or headline-grabbing as rockets. For the quickest and most cost-effective trip to near space, they are the time-honored gold standard.
Satellite missions can take 5 to 7 years and millions of dollars to develop, where scientific balloon instruments can be developed on a shorter time frame and much lower cost.
From atmospheric studies to the origins of the universe, they have been the vehicle of choice for some major scientific discoveries. And new super-pressure technology, along with sub-arcsecond pointing capability, put scientific balloon performance on par with satellites for certain types of science. An Austrian prince named Victor Hess is a key figure in understanding where scientific balloons have come from and how they're evolving. Hess loved hot air balloons and physics. In the early 20th century, he combined his two passions in making a series of daring high-altitude flights above 17,000 feet. The aim was to measure high-energy particles in the atmosphere. His discovery of cosmic rays landed him the Nobel Prize in Physics in 1936. He was also the pilot of the first scientific balloon. Fast forward to the end of World War II and a man named Otto Winzen. He devised a way of sealing thin polyethylene film with load-bearing tape. His helium-filled balloons made it possible to fly very large and heavy payloads.
He got a patent on that in 1950, and those early balloons were so large they didn't have any way to launch them, except they actually launched them from aircraft carriers.
Modern scientific ballooning was born. The first spacesuits and other pioneering technologies designed for the space program were flown and tested on high-altitude scientific balloons. With the modern space program now at the forefront, Winzen's balloon became a workhorse for carrying large scientific payloads to the edge of space. These balloon-based experiments began to train generations of young scientists, including one named John Mather. Mather's early experience on scientific balloons would help pave the way for his groundbreaking work on COBE, the Cosmic Background Explorer satellite. COBE's measurements of cosmic microwave background radiation would help to seal the Big Bang Theory and ultimately win Mather and his colleague George Smoot the 2006 Nobel Prize in Physics.
Stephen Hawking said it was the most important scientific discovery of the century, if not of all time. And a few years after that, we got the call to go to Stockholm. And so, tremendously important result of the balloon program.
Individuals can have a part in every stage of the process.
John Grunsfeld, former NASA Associate Administrator and astronaut, worked on scientific balloon payloads while earning his PhD.
The first time I saw a balloon launch, helium was in the bubble, it was on the spool opened up, and I heard the rustle of the polyethylene and saw it rising, and then the balloon took off and off it went. I thought, this is just the coolest thing ever. I went on to do 3 Hubble Space Telescope servicing missions. And for that, it was much more like scientific ballooning, because there was a moment where I was inside of the Hubble Space Telescope, this time in a spacesuit, working with tools, reaching inside of the Hubble, and I had a flashback right to that moment on the flight line, reaching into my balloon gondola. And the thought that I had at the time was, all of those lessons that I learned in building the payloads, preparing them for flight, was preparing me to go service and upgrade the Hubble Space Telescope.
With a superpressure balloon, if you do a 100-day flight, which is what our ambition is for a superpressure balloon, it's space mission science. It's 100 days at that altitude. It's 100 days in space. Yep, since you're not the flight. It's 100 days at that altitude. It's 100 days in space.
Balloons are a stepping stone to space. So this is our growth system for future brilliant people and future brilliant projects.
The scientific ballooning program offers the opportunity to get new technology to space faster than we could ever do with a rocket program to send things to orbit. What the new scientific ballooning capabilities are offering us is a technology. The need is there's lots of great science to be done that we can do on these platforms at lower cost and get the important training to be able to test out instruments. And so now we've met a need with a technology, and that's real innovation.
It's one of the best kept secrets of space science. It's one of the best kept secrets of space science.